Welcome to this video about transformations of trig graphs. Specifically in this video, I'm going to be talking about sine of x. Before I go any further, I want to explain that these videos take a lot of time, and I've already made several failed attempts. So in order to get this video done, I'm possibly going to have a few mistakes in it. I apologize. Alright, we have learned the graph of sine and cosine, and now what we want to do is to treat them as parent functions. We need to learn the feel of the sine graph, and from that we will then be able to graph transformations. So let's first make sure that we understand the feel of sine x. Remember that we said you can choose a unit for 1 in the y direction, and then once you set that unit for 1, if you go 1.5 of those units in the x direction and set that as pi halves, you will then make the graph proportional, square, true to its shape. So 1 unit in the y direction, go 1.5 of those in the x direction. That is going to set up your axes in a very, very nice way. And don't forget, of course, that we can also go in the negative x direction. So I've set up my axes here, and I'm going to start graphing points on the sine function. We know that sine of 0 is 0 because thinking about the unit circle and the wrapping function, if the angle is 0, I'm talking about the point 1, 0. The output of that for the y coordinate is 0. So sine of 0 is 0. And then if we continue around on the unit circle, we know that at pi halves, sine reaches a high point of 1. When we keep going, sine at pi is 0. Sine at 3 pi halves is -1. Sine of 2 pi is again 0. Back over here, sine of negative pi halves is -1. These high and low points have a more technical name. We know that they are called relative extrema. So this is a relative maximum, and this is a relative minimum on the graph. And so basically, we kind of want to learn one cycle of the sine graph. I'm going to just draw this in real briefly here, that this is one cycle of the sine graph, what's called one period of the sine graph. And we're going to need to shape that up a little better in just a second, but here's the overall idea of what we want to learn about the feel. First of all, instead of thinking about that as the origin, as the point 0, 0, I want to think of that as a point on the midline. These graphs are symmetric about a line. In this case, that line is y equals 0, but with transformations, that midline is going to move around potentially. So instead, I learned that the feel of sine is that I start at a midpoint, I go to a high point, then I go to a midpoint, then I go to a low point, and then I go to a midpoint again. So sine starts at its midline, one cycle or one period later it's at its midline again. Halfway between those it's again at its midline, and then a quarter of the way we have the high point and the low point. But we want to shape this graph up a lot more nicely, and therefore we're going to put in a few more points to help us. And what we need to remember is that we have a lot of in-between points we could choose, but the best one is the ones that have to do with a half. Nobody wants to deal with square root of 3 divided by 2 or square root of 2 divided by 2, so the ones that deal with a half. And for sine, we know that that occurs at pi 6, and that pi 6 is exactly 1/3 of the way towards pi halves. And so if we were to go 1/3 of the way towards pi halves, we're going to go up halfway in the y direction, up to 1/2. That relationship is very, very critical to understanding the feel of sine. That if we start with a point, a midpoint, we can go 1/3 of the way in the x direction towards a higher low point, and then go up halfway in the y direction. That relationship is very important. 1/3 of the way in the x direction from a midpoint, 1/2 of the way up in the y direction. And I want to emphasize that that is from a midpoint. A common Mistake that students make is that they try to do this starting from a high point, and that's not what we do. We can do that from any midpoint. So from any midpoint, we can go 1/3 of the way in the x direction towards a high point, go up halfway in the y direction. From a midpoint, we can go 1/3 of the way in the x direction, go 1/2 the way in the y direction, although in this case that means to go down. 1/3 of the way in the x direction, 1/2 the way in the y direction. And even back here, same thing from a midpoint, going 1/3 of the way in the x direction, 1/2 the way in the y direction. And that actually gives us a lot more points that are very, very nice to help us shape this. Because two things tend to happen for students. They tend to draw sine very, very zigzaggy, and sine is not a zigzag, so we don't want that to happen. The other common thing is that people tend to draw sine by using basically a bunch of semicircles looped together, and that also is not a correct way to draw sine. You can see this, that if I kind of connect these points, I'm going to have to sort of curve it and take my time curving it in order to actually have that match up with that high point. So these points here were really, really important to helping me shape that graph up. So now I'm going to go in and try to draw a pretty decent graph here of sine. It's difficult on this whiteboard to do that. Let's see what I can manage here. So what you should notice is that as you're drawing down here, that curve kind of gets extended out, that those little points in between cause us to actually extend out the graph, extend out that curve a bit, right? To really stretch that out. So that's why those points are so important. And by the way, those points I am going to call non-baby points. Non-baby points, because pretty much anybody that knows the graph of sine knows where it hits its middle and knows the high and the low points. Those are easy. Those are easy enough for anybody to plot. But we want these extra in-between points that are a little, a little more challenging, and so I call them non-baby points. And they're very critical for us. By the way, at this point, I want to let you know that I have upped the conditions and criteria for graphs. So you now need to label 5 points on the graph. You need to label a relative maximum. In this case, that would be pi halves 1. You need to label a midpoint. So for example, maybe pi 0. You need to label a relative minimum, such as 3 pi halves, -1. But you now must also label 2 non-baby points. This one being at pi 6th, 1/2. You also have one over here that, if you know your circle well, is at 7 pi 6th, -1/2. So that's the criteria for graphing sine and any of our trig graphs. So the key here is going to be to understand this relationship once you set those kind of quick, easy points there, that you can then put the in-between points in there by using this 1/3, 1/2 type of feel. So now we're ready to go tackle a new graph here, one with a transformation. We want to graph g of x is equal to 3 sine x plus 1, and the thing you need to understand is that that plus 1 is on the outside of the function. If I meant for that plus 1 to be inside of sine, I would have needed parentheses around the x plus 1. So both of these transformations, the 3 and the plus 1, are outside and affect the graph vertically. The 3, of course, is stretching it vertically, and the plus 1 is shifting it up vertically. Order of operations tells us that the 3 should come first, and then the plus 1. We should stretch and then shift up. But because of the symmetry of this graph, we actually are going to be able to circumvent that a little bit, and we are going to set the midline first. We're going to take the middle of the graph and just go ahead and move it up 1 unit. So let's begin. First, we're going to mark out our axes, but we kind of need to know how to mark that out. So let's think about this. Sine used to go 1 above its midline and 1 below its midline, but we're stretching it vertically. Stretching that vertically means that it's going to go 3 above its midline and 3 below its midline. But the midline now is at 1. So 3 above 1 is 4, and 3 below 1 is -2. So I need to be able to create a set of axes where I can mark 4 units in the positive y direction and 2 units in the negative y direction. And then if I want things to be proportional, remember that we take 1.5 units from the y and mark that in the x as our pi halves. Now we don't have to label every single one of those, so I'll just mark the pi and the 2 pi. Over here I can mark the negative pi halves also. So we've laid out our axes. The next thing I'm going to do is I'm going to draw in that midline. Now what I want to do is I want to just very lightly dot that in. You do not actually want to draw a dashed line, because a dashed line we would think of as an asymptote. And this is not a horizontal asymptote for the graph. It's just a line of symmetry that helps us to shape the graph. So we dot it in very, very, very lightly. All right, so here we go. Let's go get those major points for sine. We have learned that the feel of sine is that it starts at its midpoint, and then we go over a quarter of the period, in this case pi halves, that's a quarter of the way through the first cycle, and we are going to go up to its high point. But now, because of that vertical stretch, we know that that high point is 3 units away from the midline. So we now have a point there at pi halves 4, 3 above the 1. And then we just repeat this pattern. So we had a midpoint, we have a high point, so now again we have a midpoint, then we have a low point, 3 units below 1 puts me at -2. We have a midpoint again, we have a high point again, etc. Okay. Now it's time to go in and put in our non-baby points, the points that are going to help us to really shape this graph. And the feel of that again is that we start at a midpoint and we go 1/3 of the way in the x direction, and then we go halfway in the y direction. Notice that I've always said halfway rather than half. That's because we actually want to go half of that stretch, of that vertical distance. So I'm actually going to go up a distance of 3 halves. Go up a distance of 3 halves. So repeating, from a midpoint, I go 1/3 of the way in the x direction. I go 1/2 of the way in the y direction. From midpoint, 1/3 of the way in the x direction, 1/2 the way in the y direction. Here in this case, going 3 halves units below the 1 puts me at -1/2. So again, 1/3 of the way in the x direction, 1/2 the way in the y direction. And remember that that always starts from a midpoint. Okay, so I've got my non-baby points in here that are going to help me shape this graph, and I'm ready then to try to draw in that graph. It's kind of difficult here. I'm going to try. This one's going to look a little more zigzaggy just because of that stretch, but hopefully those non-baby points are helping me to shape it up better. Kind of missed a little bit there. All right. The end of that graph didn't come out so good, and I do want to talk about the ends of the graph if I have time. On the end of a graph, if you're getting close to a high point, you need to actually show the turnaround, but you need to show it so that it looks like it's symmetric over that high point. Don't just sort of go up there and, make it abruptly change directions. If you're not close to a high point, a really nice place to end a graph is just right there after a midpoint. That's a good place to put your arrow. But you don't want to put your arrow up here near the high point. That would maybe suggest to somebody that the graph is going to continue up forever. And that is certainly not the case. All right, so I only have a little bit of time here to finish up. Let's talk about labeling that non-baby point. We know the graph, the unit circle, and the wrapping function well enough to know that that point that is 1/3 of the way back from pi towards pi halves is actually 5 pi sixths. And we know that this distance is 3 halves, 1.5, but it's 1.5 above 1, which is 2.5, which of course we label as 5 halves. So you can find various non-baby points. We also need to label a relative minimum, and a midpoint, as well as one more non-baby point.